so we can have that done at 6 frames per second. I don't know if anyone's actually watched the videos. They're apparently in standard definition because that's the definition that this thing does. I don't know if I can change that or not, but all right. 3 cans on a shelf. Coke, Pepsi, Red Bull. So we're going to look at today when things are the same. Just after I can't remember. I thought one of them was, maybe not. So there's 3 objects. So if we talk about what we did yesterday, this would be 3p3 or 3 factorial. Oh, that's not what I want. There's Grace. Grace is very much quieter on this than she is in class. In which we can work this out to 6. I want to write them out for a reason. So we can have Coke, Pepsi, Red Bull, Coke, Red Bull, Pepsi in that order. We could have Pepsi, Coke, Red Bull, alphabet problems, Pepsi, Red Bull, and Coke, and come on, brain. Oh, Red Bull, Coke, Pepsi, Red Bull, Pepsi, Coke. So those are, for a small group, those are all the possible permutations, the only ways to organize those on a shelf. But what happens if I switch that? So I'm going to group those, copy them, paste them. Oh no, what just happened? I want to buzz off. Put those down there. So if we switch these, then I'm going to change that to a Coke, that to a Coke, that to a Coke, that to a Coke, and that to a Coke. Doesn't, oh, here, I'm going to do this different. Let's do this the smart way. I'm going to scratch that off, put a Coke. Scratch that off and put a Coke. I don't know if this is actually better. Coke. So, still 3 cans. Still 3, we have to do that. But now, which one's PCC, PCC? Are those the same? Yep. And then we have Coke, Coke, Pepsi, Coke, Coke, Pepsi. So this one and this one are the same. And just for Coke, Pepsi, Coke, this one and this one are the same. So how many permutations are now that we have something extra? Well, we went from 6 down to 3. The kind of key thing is how many things are the same? 2. What can I do with those? Permutations of n objects where A are identical and B are identical and C are identical is n factorial divided by, so this is all of the objects. And these are anything that repeats. So we can do this for a bigger number or something like that, but we don't have that kind of time. Plus, I don't want to keep you here for hours and hours. Let's write that down.
Vietnamese.
So there's some kind of typical questions with these. Oh, this is serial. Usually, I don't know. Oh, I guess I don't have it here. Sorry. So Beck bought a carton of 6 boxes of mini cereal. 3 Cheerios, 2 Fruit Loops, and 1 Mini Wheats. Over a 6-day period, Beck plans to eat the contents of 1 box of cereal each morning. How many orders are possible? Well, it all depends. Are you crazy like Mr. McKay? And, well, I don't know. It's tough. There's 2 things. Do you delay the gratification and eat all the Cheerios first, then the Mini Wheats, and save the best Fruit Loops for last? Or do you just eat the good Fruit Loops first and then at the end be disappointed? I'm probably going to eat the Cheerios first. But the total ways to arrange 6 objects is 6 factorial, or 6p6. But the 3 Cheerios are the same. The 2 boxes of Fruit Loops are the same. Do we need to do anything for the box of Mini Wheats? Not really, because there's Paige. There's Paige. We're up to 16. Quiet, quiet, Paige and Grace. We're almost as quiet now as Lauren is in class normally. I'm so trying to goad people to turn microphones on. So we can work this out. 3 factorial, we just said was 6. 2 factorial is 2. 1 factorial is 1, so it's kind of redundant. Why did I write 3 when that's 6? 6 times 5 is 30. 4 30s are 120. 3 120s are 360. Times 2 is 720. $60?
Where do we get the 6 times 2 for?
So 3 factorial, if we work that out, that's 6. This is for the 3 boxes of Cheerios because they're the same. And then the 2 factorial. Oh, fruit. I misspelled it there because Fruit Loops are actually 2 O's. So anytime you have something that repeats in an order, we have to kind of take out the fact that those 3 boxes of Cheerios, they're the same in terms of, well, one is the same as the other, so we just work that out. So Beck could eat those boxes of cereals over 6 days, 60 different ways. We could do McKay's, Cheerio, 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 Mini Wheats, Fruit Loops, and we could list all of those possible ways. But whether this is C1, 2, 3, well, if you do it, those are equivalent because you're still eating a box of Cheerios first, second, third. So we have to take that into account. That's why we're doing that division. All right, this takes forever to do. The grade 10 stuff where it's day by day is fairly small. So we're just going to, if we have 14 things, and then we'll divide out. Do we have the traditional, flags. Then we have these words. Try.
Mr. McKay, are you recording this one?
Yep.
Okay.
Do you have to go?
No, I just didn't see it.
Oh, okay. Nope. I tried to record them all. But there is a chance that I don't, because I've done that in the past. And for you guys, it would suck because I don't have to do, if it was a grade 10 class, I would just do another one. So old-fashioned, like naval symbols, they like draw up flags and they mean different letters and all that sort of stuff. So 6 flags. If we have 3 green, 3 red, 1 green, and 2 blue, or 2, how many different possible orders can we have? Well, we still have 6 flags. So we're going to start with 6 factorial. But the red flags can be done, well, this is boring because this is the same as the one that we just did. 3 factorial for the red flags. The 1 green, just 6 flags of any color. I can't really use white. I'm going to put this in for the green one. The 1 is redundant. You don't have to do the 1. And there's 2 blue flags. 6 factorial was 720. This is 6. This is 2. So with that combination, there's 60 different characters or words or whatever that can be made. So this is like if you have a boat. Oh, this is going to be bad. Boat, mast, sail. From the mast down, there's lines. And you can put different flags. And they mean different things. Like that. Well, there's still 6 flags. So that's 6 factorial. But now we have 2 red, 2 green, 2 blue, 720. I'm not going to change colors again. 2 times 2 times 2. 2 times 2 times 2 is 8. So if you switch one of the red out for another green, you actually get a whole bunch of different possible orders. And this is, again, I don't want to write all 90 orders. Red, red, green, green, blue, blue. Red, red, green, blue, green, blue. Red, red, blue, green, blue, green. And all of that. These are kind of the traditional things. Determine the number of permutations of all of the letters in the following words. Well, the real traditional one is Mississippi. M-I-S-S-I-S-I-P-P-I. I-P-P-I-S-S-I-S-S-I-M. But there's 1, 2, 3, 4, 5, 6 letters in Sussex. 6 factorial. The S's repeat, even though, I mean, we're not going to take into account that that's a capital and those are lowercase. It would be 3 factorial. I got to come up with a better number. 3 times 2 is 6. And that would be, there's 120 different ways to arrange all of those letters. If you don't believe me, try. It would take a long time. I had one kid who thought they would be smart and they would try, and it's like, no, don't waste your time, man. Statistician. Wow, that has a lot of letters. 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 6, 9, 12 letters. So there's 12 factorial. Oh, we've got 2 S's. I sometimes like to do this for the T's. 2 factorial. The A's. Oh, I got to extend that. O. And here's one thing I got to worry about is what happens if you spell the word wrong. That gets to be a little bit tricky. That's 2 times 6 times 2 times 6. It's 12 times 12. So this is going to be over 144. I honestly have no idea what 12 factorial is. It's 3 million times 100 and something. 479,001,600. Hope I did that correct. 479,016 divided by 3326. I think it was 400. Why would you do that? Belial or Belial, depending on how you would like to pronounce that. 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 factorial ways to arrange 9 objects. But I see 1, 2, 3 E's. 1, 2, 3 L's. Uh-oh. Good day. 19 minutes, wow. Where is the time going? 3 factorial is 6 times 6. Whatever this 9 factorial is, over 36. Come on, you piece of garbage. 9 factorial, 362, 880. $10,000. Well, I think that's what it was. Whoops. 10,080, not 10,800. So these are ones where, I mean, yeah, the final answer is important, but if you understand where we're kind of going with those, then we don't have to, like, I trust you, most of you can use a calculator. Some of you maybe not. Oh, let's put some restrictions in here. How many ways are there to arrange the words in Canada? But the first letter must be an N and the last letter must be a C. I would, personally, so I'm going to look at the N's. Well, how many ways are there to put an N in the first spot? Well, 1. How many ways are there to put a C in the end? 1. So we have 4 words. So we've used those. So that's 4 factorial. But we've got 3 A's. So those are all going to be the same. Well, 4 factorial divided by 3 factorial is just 1 times 4. So there's actually only 4 possibilities. The D in the first spot, the D in the second spot, the D in the third spot, or the D in the fourth spot. So this is an example that came out of my children's, putting a block on top and a block and a block and a block. Three red, 5 blue, 2 yellow, and 4. We're putting them in a single tower, trying to stack them up to the ceiling. How many ways are there to do those? Well, so we have to have a yellow. I'm going to do it horizontal just because it's a whole lot easier for me to write it, because I don't want to write vertical. Sorry. 3, 5, or 8. So there's 12 blocks. How many choices are there for that first spot? Bottom of the tower. 2. Because you could have the one yellow block or another yellow block. How many choices are there? Well, there's 1 because the other yellow block is way down at the end. But now we have these 12 blocks in the middle. So there's 12 factorial ways to arrange 12 of them. But we've got 3 factorial for the red, 5 factorial for the blue, 4 factorial for the green, red, blue, and green. And so I can say 2, like essentially that's going to be 2 times that. That's 12 factorial divided by bracket 3 factorial times 5 factorial times 4 factorial, close the bracket, so the 12 factorial, and then those are all in a bracket, so that should be everything. There's equals, so this is equals 2 times 27,720, 54, 55,000 and change. So far, so good. I think there's only one more set of examples. Pathways. So these are some traditional kind of repeat type things, and there's kind of a trick. And then we have one that we have a point C. And then there's some questions to try, and that's it. Julie's home is 2 blocks north and 3 blocks west of her school. How many routes can take? So this is home, school. So I'm not going to do all of these. Julie could go south, south. She could go that way. And I don't have, she could go south, east, 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 south, east, east. Oh, sorry, colors. Like she could go any one of those ways, plus she's got zigzags and all of those. But how we can kind of simplify this and figure this out, she's got to go 1, 2, 3. She has to go 5 blocks. Regardless of, assuming each block is the same length, yada, 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 she's got to go 5. So that was 3 of the possibilities. So, well, if she's got to do 5 things, how do you arrange 5 things? It's 5 factorial. But there's 2 different, like she could go south in her first thing or second or over here. So we're going to, it's like a repeat. So this is for her south, 3 factorial for her east, because whether she goes this way, or this way, or in any one of them, they're all going to be the same. 5 4s are 20, 3 20s are 60, 2 60s are 120, 2 times 6. Come on, brain. That's 10. There's 10 possible ways that Julie can go to school. That's 3 of them. 4, 5, and so on, and so on, and so on. We don't want to, assuming 5 factorial is that, every once in a while, son of a Yeah, okay. Similar thing, how many? 1, 2, 3, 5, 6, 7. There's 7 factorial possible things, but we can go, there's 2 for the souths, so we're traveling this way. For the easts, there's keyboard shortcuts for everything, but 7? Not sure who's talking, but I counted. Sorry, 1, like 2, because like there's 5 this way and 2 that way. So this particular one, because this one doesn't have anything. It's not. It's this trip has 7 blocks that you have to traverse. So any one of these, and then we're going to look at this fun one where you have to make a pit stop in the middle, which is okay. Does that make sense to whoever said that? Because, okay, it's hard to tell voices. 7 factorial. Nope. Oh, that's for super. 7. Let's just push the button, stupid. 50, 40. That's 2 times, what did we have up there? 120. Or you can just put it all in the calculator at once. 21. Assuming I did my calculations correct. Oh dear, 30 minutes. A city supervisor with the bus department is determining the route of the bus station to go to the concert hall. Determine what? From the bus station. Well, really we want to get, the idea is to get from here to here, but we have this intermediate pinch point. So to go from A to C, there's 1, 2, 3. You have to travel 7 blocks. We have 3 factorial and then 4 factorial. And we're at that spot, but to get from there to there, well, you have to travel because it's an and 4 factorial because 1, 2, 3, 4 divided by 2 factorial, 2 factorial. 4 times 3 is 12 times 2 is 24 divided by 4. That should be 6. To get this all done at once. Whoa, not 44. Factorial bracket equals. So there's 35 possible paths from there to there. And there's 6. 1, 2, 3, 4, 5, 6. Those are, well, the possible paths. It's a B. And then we can multiply those two together. So there's 210 ways to get from the top right, top left to bottom right. Hopefully that's okay. Hopefully the meeting that's going on right now hasn't been stormed out of. 4 to 11 and 13. I don't know why I minimized that. 4, 10, How many different possible? Well, those are repeated. 9 grandchildren divided by. Can you tell the book was written out west? He has a book. He has 8 novels. Oh, but they have to be grouped. You don't really have to do number 8. 9 should be okay because it's just that. 8 blocks north, 5 blocks west. So you just, the 10 is the same as this without a picture. 11. Ooh. That is, let's stick with just B because this is a little bit different. And then we have a totem pole, 7 figures with some repeats. So give that a shot, and then we'll talk about tomorrow combinations, which are slightly different. And then I'll tell you why your lock is not a combination lock, but a permutation lock. And I will export this. Not that you guys need to watch this, so I'll wait. So if you don't have any questions, it's 7 degrees now. It's better than the 0 it was this morning. We'll get some fresh air, do a little bit of math homework, and we'll see you tomorrow, hopefully for the last day of this online stuff. Because hopefully Blaine Higgs can dig his head out of his backside. You have a question? About what? Oh, just a sec. Cancel. Where am I? Up here. This one?
Yeah. How did we do the first part of the multiplication? How do we get 35
I just did it on the calculator. That's 7 factorial. 3 times 2 is 6. So I'm going to divide that by 6. Did I do this wrong? 4 times 3 is 12 divided by 24. Yeah, I just put that all in the calculator at once. Just to turn this on. 7 factorial should be 5,040. 3 factorial is 3 times 2, which is 6. That's 24, right? Okay. Well, that should make 35. Okay. So if you're good, we shall see you tomorrow. Have a good afternoon. Participants. Because eventually they're going to make me do attendance. Bye. Leaving. Oh, to think of hours, fall asleep. Oh, Mark didn't. See you later.